NSP. Every node has a number. Remember the slot numbers and then port. NSP, node, slot, and port. Okay, and since we're talking about this, I'll bring up the slide where we were, showing this yesterday. So let me find it here. So yeah, here's where we were. Remember, each node. Let me use my point here. Every node has a node number, 0, 1, 2, and 3. And every slot has a slot number. Slot 0 are the SAS ports for back-end disks. Slot 1 is the onboard 8 gig fiber channel ports. Slot 2 is this optional slot, what we call the optional HBA. We went over yesterday, what are your possibilities in terms of the optional HBA. I know at least in one pair of your controllers, you have the 2-port 16 gig fiber channel card there. That's slot 2. And slot 3 is the 1 gig Ethernet port, which is used historically for remote copy, but can also be configured for the file services, file persona, what's called a file FSIP port, but that's slot 3. And if you just look at this one example here, follow the red bouncing ball, the port number is node 0, slot 1. This is 2, so it's 0, 1, 2. And hopefully yesterday in the lab you did in the afternoon, I had you drill down in the hardware, look at the ports, and even had you do some things from the command line, like show port. So you'll see references to the port numbers and a lot of CLI output and in the GUIs, but NSP. And then in the 7000, in your 7440, yours doesn't look exactly like this, but if this is a pair of controllers up here on the top, and this is a base, you can have, like on your 7440, up to 19 expansion cages behind a pair of controllers, technically on a 7440. And then these are expansion cages. This is the back, the IFC's interface connects, showing you a daisy chain configuration. Now remember, in your 7440, since we only support 240 SSDs, and there's a decision made, you're 100% SSDs. I mean, do the math, 24 slots per essentially cage, including your bases. You could have a total of 10 cages. So behind a pair of controllers, if this is a pair of controllers up here at the top, this is your base. The front, of course, we have 24 slots for disk. You have essentially 4 expansion cages behind one pair and 4 behind another pair, all right? So you have these, concepts of a base and expansion cages. And you're fully populated with the close to 4 terabyte SSD disks, so 240 disks. But for the disks, if you were to do like show PD, or let me pull this slide up so you can refresh your memory here. For the disks in the 7000 series, you'll see reference to disk numbers. And you'll hear the naming convention CMD, Cage Magazine Disc, although you don't have magazines in the 7000 series. So, follow the red bouncing ball. Each cage will have a cage number. Then each slot has a slot number. On the 7440s, you've got slot numbers 0 through 23 here. And then the last number will be a 0. So it's cage, slot, and then a 0, essentially, for the 74. All right. So, we talked a little bit about the hardware for the 7440. Now, one thing I should have mentioned yesterday, maybe I did, maybe I didn't, is, this class is not intended to be a very intensive hardware class. I didn't go over every port, every intrinsic piece, if you will, of the controller nodes. And but you know, as an admin, you know, we gave you a little bit of an overview. You got to know that there are bases, disks, the ASIC, cache, you know, the naming conventions for the disks and the ports, what the ports on the controllers are used for. You've got the ASIC that does the zero detection and parity calcs and so on. So the goal there, you know, was to give you a little bit of an overview of the main hardware components in the 3-part array. So let's talk about what we've got on our plate today. These first 2 chapters, we're going to go over storage concepts, terminology, and these 2 chapters, Module 5 and 6, really go hand in hand. Yesterday, you heard me touch on chunklets and logical disks and use the term volumes and CPGs. So we're going to get into concepts in terms of eventually creating those volumes and exporting them to host. So these 2 chapters kind of go back to back. The first chapter talks about CPGs, volumes, conceptually, and then in this chapter, Module 6, called Storage Configuration, we're going to show you how to, you know, administrate them with, you know, the CLI and SSMC. And then we're going to see how things go, but we're definitely going to do this chapter today. You know, once you have volumes, CPGs, etc., you have to add host, export volumes to host, and so on. Definitely going to do these 3 chapters today, and then we'll see how it goes. Depending on the time, we might get to volume sets and host sets. All right, but before we kind of move forward here, before we get going here, are there any questions on anything we talked about yesterday? Anything we discussed? Raise your hand, type it out in the chat room. Okay. All right. So this chapter, called Storage Concepts and Terminology, is really an important chapter because really we get into a lot of detail, best practices. I like to call them decision points that you have to make as a 3-part admin. Now, usually when I teach this class, I spend really a lot of time on this, at least a couple of hours, and we'll probably do that again today. But when we get into, we're really kind of talking about in this chapter, most important concept I think in this chapter is the concept of the Common Provisioning Group, or the CPG, okay? The CPG. And some of the things at Bank of America are already set, CPG-wise, if you will. And once I get into this, I'll explain what I mean by that. But it's important to know what your options are in terms of administration of this array. Sometimes I get from students and customers, they'll say, well, what's the best practice? You know, for instance, we're going to talk about this. When you create a virtual volume, you can choose a RAID level, RAID 5, RAID 6, RAID 1. People ask, well, what's the best practice HP publishes? Well, kind of hard to say. I mean, you want to think about things from a cost point of view. You know, what's best practice from a cost point of view may not be, you know, optimal, if you will, from a availability or performance point of view. From an availability point of view, RAID 1 is best. But it's the most expensive RAID level of the RAID levels we're going to discuss. So really, you know, eventually you have to make decisions. And we're going to talk about concepts and terminology in this chapter. We're going to talk about some provisioning terms. Yesterday I mentioned the term chunklets. I'm going to get into a little more of that, and what's called a logical disk, or an LD. But this is kind of the main thing in this chapter, common provisioning groups. Once you have CPG set up, you're going to create these volumes, VVs. There are 3 types of volumes: the fully provisioned, the thin provisioned, and the thin deduped. At the thin dedupe volume can only be allocated from SSD capacity. And remember, one thing I want to point out here as we move forward in this chapter, and this is where maybe some of the things we'll get into here won't really apply to Bank of America, because remember, it's possible in 3-part arrays, we support 3 media types, what we call the solid state disks, the SSDs. You'll hear the term FC disk. This is a reference to the 10K and 15K SAS disks we support in the 3-par arrays. Then we support what we refer to as a near-line disk, which is this cheaper, slower, but it's cheap and they're big, 7.2K disks. So we technically support 3 types of media in your 7440, but remember, you know, you're 100% SSD. All of your disks are SSDs. So I believe that, and so thin dedupe volumes can only be created from SSD capacity. So you're 100% SSD, so that's good. So you can create thin dedupe volumes. So I believe you're doing thin and thin deduped volumes on your array. So we'll get into some of the specifics on thin and thin dedupe. Ron, you have a question?
Yeah, you may have actually answered the question, but just I know I'm reiterating a little bit. Just need to make absolute sure I'm hearing this right. No matter what kind of mix that we may end up with in a particular array, as you said, good news is we're using SSD. When you say thin deduped, and you're going to be going into this deeper later, but when you say thin deduped, so the only time I can dedupe anything is when it's SSD. I mean, that's just it.
Right.
Or can I do like a thick, let's call it a thick dedupe?
Well, no. So a thin dedupe volume is essentially a thin provision volume, but we do deduplication on top of it.
Right.
But a thin dedupe volume can only currently be created from SSD capacity. All right. So you can't create, so first of all, there is no kind of concept as a fully, like a thick or a fully provisioned deduped volume. It has to be thin.
Okay.
So our dedupe is really a thin provision volume created from SSD capacity, and we do deduplication on top of it.
Okay.
And so I'll give you some of the kind of how it works a little bit, but right now, see, we just introduced the thin dedupe volume last year. And, you know, with HP's emphasis on flash, you know, adaptive flash cache, the all flash arrays, and, you know, and then we introduced thin dedupe for SSD capacity. Our emphasis, a lot of our kind of new features involve flash, right? The SSDs. So our first stab at it was, you know, do thin deduplication on SSD capacity, right? And not in the next release of 3-pars, but there is talk that we're going to also do deduplication on, you know, the FC and definitely the FC, maybe not the nearline capacity, but currently it's deduped only on SSD capacity. It's a thin provision volume. Basically,
All right. So
on top of
you're going to talk about the things like when you actually do a dedupe and you know.
Well, I'll show you how it works because you don't really do a dedupe. It's the ASIC that's going to check as the writes happen to make sure there's a 16K page. It's done in line.
Okay.
So you don't do a dedupe.
Is post dedupe.
What's that?
Your real time as opposed to
Right.
Data at rest.
Right. So data at rest is an encryption. So deduplication, our data at rest feature, what we call, is doing data encryption when the data is written to what we call an SED, a self-encrypting disk. The data is actually encrypted. Here, the goal is, you know, this is where I kind of have to explain, give you some foundation in terms of our volumes. But eventually what happens when a host writes, you know, like I have a host writing to a volume to the array, eventually the host is going to write to cache. And our cache is essentially chopped up in these, what we call 16K, let me write this out here, 16K CMP cache management pages. So essentially there are a couple of steps here, but eventually a host sends a write request down a path to one of the controller. We've got to pull these pages from disk into cache. And then for a write, we've got to take these pages and eventually do a D stage, write them from cache down to disk. All right. So as we take this page from these pages, 16K CMPs from cache down to disk, they contain duplicate data. You know, like if these 3 pages contain duplicate data, we're only going to need to write that 16K worth of data out there once. If it's written a second, third time, we're just going to discard it. We're not going to actually write it a second and third time. All right. So it's done inline by the ASIC as the writes come in, our B stage from cache down to disk. This is where I got to give you some detail on volumes in general. But with the dedupe process, if these blue pages are duplicates, it's only going to be written out there once and be shared by multiple.
I'll save any of my other questions for when you actually get to it. But thank you. That's
sure.
That's
So yeah, we'll get to some concepts how it kind of works behind there. You don't actually do the deduping. It's the ASIC that checks for duplicate pages. But I got to get into some things in terms of CPGs and how it works here. In general, how our volumes work and how the space is kind of, laid out and so on. So, and then in fact, I've got a little chapter. Maybe I'll pull it in today. I was going to do it tomorrow, but we'll kind of see how it goes. I've got some specifics on thin dedupe, but technically when you create a volume, it can be fully provisioned, and we call a fully provisioned volume a thick volume. You might even hear it referred to as a fat volume. And a thin provisioned volume, what we call a TPVV, a thin provisioned virtual volume, and a thin dedupe volume, a TDVV. All right. So we'll get into all of that. But, a little bit of a kind of big picture thing here. Let's say this is, now here I've got a host. I know you're predominantly VMware, but, if this is my 3-par array, we know we have cages and disks, etc. But, remember yesterday, just to kind of recap remember when I kind of drew this slide yesterday to explain what a virtual volume was? I've got these disks. You create these volumes of different sizes and RAID levels, and then we take a volume and export it to a host. And once it's exported, it's a VLAN. So this first slide here is really kind of a recap of that. We're going to take these volumes and export the host to a VLAN as a VLAN. So a virtual volume, or you hear the term VV, is a virtual disk and is assembled by policy. Now, yesterday when we were talking about, I gave you that introductory chapter, but I kind of used the term policy, and really, if you remember you probably don't, but very first slide, I said this is a policy-based array, and it's an autonomic policy-based array, policy managed. When you hear the term policy, or a lot of those terms I just mentioned, this is a reference to the common provisioning group. So, of course I can't spell, common provisioning group, or the CPG. A volume is exported to host normally as a VLAN, all right? When it's exported, is referred to as a VLAN or a virtual LAN. And so the host sees the VLAN as a disk. This is the only visible layer. This is the only layer visible to the host. So if I create a 4 terabyte virtual volume, that 4 terabyte volume may be eventually carved out of your 240 disks, your 240 SSDs. So, when you export a 4 terabyte volume to this host, that's all it sees. It sees a disk. It doesn't see that, it's out, this host doesn't see that it's carved out of 240 physical disks in the array and RAID levels and, the cages. So it appears as a disk. All right. Now, there are a number of building blocks, if you will, to create these virtual volumes. So that's a segue to this slide. We know we've got disks in our cages, PDs, an acronym, physical disk, or a PD. Now, your physical disks, remember, are all SSDs currently, and they're close to 4 terabyte SSDs. So you've got your disks populated in the drive cages and so on. Now, our disks are chopped up into 1 gig chunklets, okay? So at the physical level, like on a brand new array, or let's say you were to add new disks to your array, which you can't right now because you're fully populated, but let's say you add new disks. If you add new disks to an array, we're not going to get into a lot of the details, but you have to do some things from the command line like admit HW, admit PD. But essentially what happens when you add new disks, the 3PAR-OS chops the disks into these 1 gig chunklets, okay? Now, as you create volumes, these chunklets are going to be allocated from the disk. Now, as chunklets are allocated from the disk, the 3PAR-OS allocates the chunklets. I'll give you some details on how it works, but as the chunklets are allocated to the disk from the disks, they are grouped together. Like here, these little blue squares represent a chunklet. These chunklets are grouped together into what we call a logical disk. So how many chunklets wind up in a logical disk vary on RAID level and a couple of things, but eventually these chunklets are grouped together by the 3PAR-OS into what we call a logical disk. And then the 3PAR-OS assigns a logical disk to a controller node. Let's say this one is created and is assigned to node 1, all right? So chunklets are grouped together into logical disks. Now, at the end of this chapter, I'm going to kind of come back to some concepts here in terms of logical disks, so on. And when I talk about this slide, I like to say this to my students. I mean, we're going to get into some details in terms of logical disks and chunklets and a couple of other things. But as an admin, you don't create chunklets. You don't work really with chunklets, and you don't work with logical disks, okay? As an admin, you work from here up. You work with and create and do some things like maybe even delete and edit common provisioning groups. It's a virtual pool of LD space, manage the creation and dedication of the volumes. So as an admin, you really do from here on up, okay? You work with common provisioning groups, create volumes, virtual volumes, then deduped, maybe fully provisioned, delete them, snapshot them, export them, DO2 them, and then, we take these volumes and export them to hosts or host sets, okay? Which we're going to get into host sets a little bit later on today. So I'm going to give you little detail, which is nice to know about, particularly in logical disks. Chunklets are chunklets, I'll give you some details. There are a number of, actually, there are a handful of pieces missing here. Not missing, but there are a couple of other components, if you will, for the volumes. As I mentioned one a little bit earlier, like a 16K page. But we'll get into I'll give you some detail on how things are kind of carved out of the disk, how the space is allocated when you create these volumes, plus a little bit, plus a little bit on the dedupe process as well. But we're going to focus mostly on these two things here, working with CPGs and working with volumes. And then later on today, we'll show you how to add hosts and export and unexport, so on. All right. So this, again, another one of these kind of big picture things I like to say. Now, if we kind of work our way up, we've got our disks. Our disks are broken down into chunklets. Now, every physical disk, every PD is broken down into an allocation unit called a chunklet. This is fixed at a gig for your 7000 series, all right? Your 7440, all right? Now, one thing I want to point out just for reference, if you're reading documentation or even some of your student notes and so on, you may see reference to a 256 meg chunklet. Some of the earlier 3-PAR arrays back in 2007, 2008 that we still support, we don't sell those arrays anymore, still support them, had a 256 meg chunklet size. But back in 2011, we changed with one of the releases of the 3-PAR OS, the chunklet size to be a gig. So in your 7000 series, your 7440, you have a 1 gig chunklet size. But, just to point out, if you see some references 256 meg, it's an array you don't have. So now this chunklet, you don't create chunklets, this third bullet item, you don't create chunklets. You can't change the chunklet size. It's the smallest unit of measure and makeup of a volume at the physical level, okay? They're kind of the first building block physically when you create the volumes. And you want to think of them like little miniature disks. this is a disc over here and these little purple chunklets, these are the chunklets. You want to think of them almost like little miniature discs, or this disc here, this one disc in silver, is chopped up in all these chunklets. You want to think of them like a bucket of chunklets. And some chunklets are set aside for sparing, as we talked about yesterday. The SCs down here, the spare chunklets, those are a gig as well. I do have some detail in your student notes in your book on the sparing policies, and we touched on it a little bit yesterday, but today, what we're focusing on is using not spare chunklets, using these chunklets on the disk for creation of the volumes, the virtual volumes or the VVs. Now, there are the uses for the chunklets on the disks, like for instance, snapshot copy space and physical copies. There's some admin space. But for purposes of today, we're going to talk about these chunklets being, kind of the foundation for the volumes. All right. Now, if we look at this picture up here, this is similar, kind of an excerpt from a slide we looked at yesterday. If these are my disks up here, let's assume these represent, some of your SSDs in your 7440. The disks are, these different colors here represent the chunklets. Okay, so let's look at the bullet items here. Why do we use chunklets? The same disk, your same SSD, can serve as many volumes with many different RAID levels at the same time. Basically what we're saying here is if you create volumes, eventually we're going to create volumes across these disks here, grabbing these chunklets, details on how this works to follow. This disk here might have pieces, if you will, of multiple virtual volumes, right? Here I have 4 volumes carved out of these disks. If I lose this disk, or this just focus on this disk right here, and this one right here, this has pieces, if you will, of multiple, pieces of the 4 volumes. So a volume, a drive spindle or a disk can have kind of service many virtual volumes. The volumes can be different RAID levels, sizes, etc. Why we use chunklets and 3PAR, enables our array, the 3PAR array, to be managed by policy, not by administrative planning, or I like to say, not so much at the physical level. The fact that we use chunklets drives up the utilization rate of the disks. There is, in the 3-PAR array with our disks, very well utilized. You're not going to have a lot of unused space because we use these chunklets. That's great from a performance point of view. That's great from a cost point of view. That's actually, the fact that we use chunklets is great from an availability point of view as well. We use some of those chunklets for spares, and as we move forward this week, when we talk about features like dynamic optimization and doing tunes and adaptive optimization, which you're not going to use adaptive optimization. The fact that we use chunklets really kind of enables us to use some of the features. Now, down here at the bottom, they use the term chunklet grouping. Okay, chunklets are autonomically grouped together into pools by drive rotational speed and type. Now, here's what they're saying. Okay. In the 3-PAR arrays, we support nearline FCs and SSD disks. All right. Now, I know this doesn't apply to you, but let's say I have customers who have a 7000 series or even another model like the new 20,000s or 8,000s. If a customer I have does have a mix of FC, nearline, and SSD disks, let's say a customer, let me just write this out here. Let's say I have a customer that has just 24 SSDs across their, drive cages. They have some 15K. Let's say they have, 24 of those across in their array. And maybe they have some what we call nearline disks, which are the 7.2K disks. Slow, but cheap and big. Let's say they have, 16 of those. small, small number, small array. So 24 SSDs, 24 FCs, and 24 nearline, or sorry, 16. I'm sorry, excuse me. They have 16 nearline disks. Now, however many disks of a certain media type, they have X number of SSDs, X number of FCs, X number of nearline disks. You want to think of these disks kind of these, like in example here, I have 24 SSDs. All of those SSDs are chopped up into chunklets, and you want to kind of think of it like a big bucket or big pool or bowl, if you will, of SSD chunklets. And if a customer had, 24 FC disks, all those disks are chopped up into chunklets, and it's their FC chunklets. And by default, when you create a virtual volume, whether it's thin deduped, or fully provisioned, a volume can only be allocated from one media type. So let's say I have a customer with a mix of these 3 disks, types of disks. Maybe they'll create volumes from, certain volumes from their FC capacity, maybe volumes that are just for testing, performance is important, so these are slower disks, create volumes using their nearline capacity and their more performance critical volumes that are going to be used for their more business critical or performance critical applications, use their faster, most expensive SSDs. So when you create a standard volume, if you did have a mix of these media types, the volume can only be created from one media type. In other words, let's say a customer has these 3 media types, they want to create a 2 terabyte volume. They can't say, well, put half the chunklets for that volume on the nearline capacity and half of it from the FC capacity. So if I had a customer that did have these media types, they have to choose when they create the volume which media type they want to carve it out of. Now, of course, that doesn't apply to you, right? Because all of your disks are SSDs currently, all right? So when you create a volume, or any volume, it's going to be, allocated from one media type because that's all you got. Well, give me just a second. Let's get to RAID levels in a little bit, okay? I'm going to talk about the RAID levels, but essentially the RAID is done. It's actually done at the. It's not done at the chunklet level. It's actually done at what's called the region level. But hold that thought. It is actually done at the disk level. When you're using those terms, I've got to go into Manoj some other details on how the volumes, and I haven't even, and we'll talk about the RAID levels here as we move forward. It is, when you use the term disk level, volume level, or chunklet level, there are other pieces to a chunklet that I haven't even gotten into yet. And give me a few minutes to get into RAID levels, and then I'll give you some specifics on that. Okay. All right. All right. Now, eventually, if you think about it, if I flip back to that slide, where I created this volume here, this red and green volume, think about it, these volumes here are grabbing chunklets on this. These little black squares represent chunklets. Now, we're using, essentially when these volumes are created, we're grabbing the chunklets on the disk. The 3-par OS is grabbing the chunklets as you create the volumes, or if they're thin, and we're writing to the thin provision volume. Now, eventually, the 3-par OS is going to take these chunklets as they're allocated, not eventually, but when the chunklets are allocated is a better way to put it. When the chunklets are allocated from the disk, for a volume, I guess, the chunklets are going to be grouped together into something called a logical disk. So let's say down here at the bottom, these represent some chunklets from your SSD capacity. These are 4 different chunklets of a gig. And these 4 chunklets here are definitely on different disks, physical disks. These represent chunklets, 1 gig chunklets on, say, 4 of your SSDs. The chunklets are then grouped by the 3-par OS into what we call a logical disk, or an LD for short. Up here at the top, an LD is a collection of chunklets of a gig, and you want to think it almost like a RAID set or a RAID set. Each RAID set or logical disk is made up of chunklets from different physical disks of the same type. In other words, these chunklets down here from, say, your SSD capacity, but they're on different SSDs. A chunklet can only be a member of one logical disk. In other words, this chunklet here can't be a member of another logical disk. And logical disks are bound to controllers. So volumes are load balanced across all the controller nodes, which gives us the capability of saying our volumes are active-active. Now remember yesterday when we talked a little bit about, I talked about the fact that this three-part array is very wide striped at a number of levels. And I said, when you create in other arrays, like in the EVA disk array, remember I used that as an example, when we create a volume in like the EVA, it's owned by a controller. So controller A might own these volumes, controller B, a number of other volumes. I mentioned yesterday that our volumes in the three-part array are not owned by a controller. They're really owned by all of your controllers. They're wide striped across your controllers. Well, why is that? Well, that's we can say that our volumes are active across all controllers because of this concept of a logical disk. All right. Let's go over here to this picture. This is similar, this is essentially your setup. Here's controller node 0 and 1 here, and here's controller 2 and 3 on your 4 node 7440. Eventually, as you create your volumes, okay, these chunklets are allocated, grouped into LDs. And then your LDs are assigned to your controller nodes by the 3PARS. This is a logical disk in green, red, purple, yellow here. These are the ones owned by these different controllers. So as volumes are essentially grow, if they're thin provision or you create the volumes, chunklets are allocated and these LDs are assigned to your controller nodes. These little white squares represent LDs. This is just an example. So essentially, when you create a volume, and I've got to give you some details on, a volume is going to write into chunklets on disks, and then these chunklets are grouped together into LDs, and your volumes are going to be wide striped across all of your controller nodes at the logical disk level. Now, on a day-to-day basis as an admin, you don't really need to know about logical disks. I mean, you don't have to worry about which logical disk winds up on which controller, which chunklets wind up in which logical disks. That's not important on a day-to-day basis to administer this array. But what you can know is that the fact that when we do use these chunklets and logical disks really leads to our true active-active LUN presentation. Our volumes in the 3PAR are not owned by this controller or that controller. They're wide striped at the chunklet/LD level, all of your volumes. All right, which is really great from a load balancing point of view across your 4 controllers. Yesterday we talked a little bit about, the fact that these controllers have cache, and so cache is very well balanced across the controller nodes. All right. Now, so chunklets and logical disks, nice to know about. Now I'm going to come back to some things in terms of chunklets and logical disks at the end of this chapter. Chunklets, LDs, good to know about. But as I said before, we started this chapter, I said, you're, as an admin, you work with CPGs and volumes. So let's get into kind of the meat and potatoes administratively where you work. Let's talk about the Common Provisioning Group, or the CPG. An understanding of CPGs is critical to administering the 3PAR array, all right? The CPGs are the policies. They act as a template that the volumes will use, eventually determine a volume's characteristics like RAID level, RAID drive type, availability cage, set size. I'm going to go over all those terms. Right now, you probably don't know what set size is or availability level is. I'll go into that. CPGs have many functions, including they are the policies by which the free chunklets are, allocated from the disk and assembled into LDs, which are really the basis for your volumes. virtual volumes. A CPG is a container of volumes used for reporting purposes. We'll get in reporting later on this week, and they're the basis for our optimization products like AO and DO. Now, probably 80% of what I just went over there said, may not make any sense or gel with you, but hopefully by the end of my conversation here, it will. So this is just kind of to start the ball rolling here. Now, CPGs. This is an excerpt from the GUI management console, and in fact, you can kind of see this up here because this is a screenshot. It tells you here from management console. But you could see the same thing in SSMC as well. If you drill down into your CPGs, what I'm showing you here is on a 3-part array, there are default CPGs created for you. Okay. Now they've drilled down in SSM. These are the names of the CPGs. Now in your array, since you only have SSDs, you will have these CPGs, SSD R1, R5, SSD underscore R6. So this essentially means by default, you can create some RAID 1 volumes from your SSD capacity, RAID 5 volumes from your SSD capacity, and some RAID 6 volumes from your SSD capacity. Now, so know for now, there are default CPGs that are created out there based on the types of disks you have in your array. You log into SSMC, you'll see these. You didn't drill down to CPGs yesterday. You will today. You would have seen these. Actually, you wouldn't. Well, I'll tell you what, you would see these up here because we don't have SSDs. There are no SSDs in your arrays you're working with this week in the lab environment. But there are default CPGs that are out there based on the types of disks you have in your array. And you're going to need to have CPGs to create volumes. Now, so you have your default CPGs, but then from there, you're going to probably create your own CPGs. So there's some defaults out there, you're going to create your own CPGs. Now, before I go over this example, all that being said, we really need to talk about what is a CPG? What is a common provisioning group? All right, so before I go over this slide here, I want to push out a little demo to you. Sort of like yesterday I was, pushing out the shares and going over the labs. Now, when I do these demos, by the way, or push out my share, it's kind of see if it's hard for me to see if you have your hand up or type something in the chat room out. So if you have any questions, if you wouldn't mind kind of waiting until I come back to the classroom and stop the share. So what I'm going to do here is share my desktop. And by the way, when I share this desktop, you'll see me, it'll pop up. And if you want to make it bigger, maximize it, you can do that. So what I'm doing here, I'm sharing my desktop. I'm on a Windows host, just like you were yesterday in your lab environment. I'm on a Windows host. I installed SSMC. I'm connected to an array. And you can see I'm logged in here to SSMC, right? Now, what I want to show you first, I'm going to pull up the mega menu. And just a couple of things I want to show you real quick. I'm going to click on the storage systems. And I'm going to use, I'm connected to 2 arrays. But I'm just going to give me, I just want to use 2, 3, 4, 5. Okay. Connected to an array here. All right. It's a 7200, which has 2 controller nodes. And then I'm going to go, that's not a big deal. It has 2 nodes. And if I go to physical, well, I can show you a couple of things, drive enclosures. I have 2 cages. Off to the left here you have my base enclosure and expansion cage. So remember that, I essentially have 2 cages. all right, which one is my base, and then I have an expansion cage, right? And just to show you this, I can actually go into the physical, well, I can do a couple things. I can go into the, cage 0 has a mix of nearline and FC disks, and cage 1 has a mix of nearline and FC disks. So I'm teeing up here, just kind of showing you that basically I have two cages of disks. One is my base and expansion. I have a mix of FC and nearline disks across the two cages. So remember that as I move forward here. I don't have any SSDs. I have a mix of nearline and FC disks across two cages. All right. Now, so let's talk about CPG. So I'm going to pull up the mega menu here, and under the block persona, the second column here, I'm going into common provisioning groups. And you can see when I go into CPGs here, I have my default CPGs that are out there. I don't have any SSD CPGs because I don't have any SSDs in my array. These are the defaults, all right? And you can work with CPGs, and I'll show you how to work with them along the way. But what I'm going to do here, I'm going to create a new CPG. Now I can click on the Create CPG button over there, click on Actions, Create a CPG. Now when you create a CPG, the wizard's going to come up, and I'm going to click on the Advanced Options button over here. So when you create a CPG, you give your CPG a name. I'm going to call mine FC underscore with my initials JFS underscore RAID 1. Now, you'll see why at the end here, why I'm naming it this. But when you create a CPG, you just give it a name, all right? And then you choose the array you want to create the CPG on. Now, I'm technically connected to two arrays, but I'm going to use it on ST3 par 5. All right. Now I'm scrolling down here. Now under the allocation, see this area here called allocation settings? What it's going to show me essentially in this device type list is the media types of the that I have on the array. So of course I don't have any SSDs, but I have some FC disks and some nearline disks. So one of the things you do when you create a CPG is you say, okay, what's the media type? SSD, FC, nearline. Now I'm going to just choose FC. And then I'm going to choose, then it's going to ask me, what is the RAID type? We support 4 RAID levels, 0, 1, 5, and 6. Now I'm going to take the default RAID 1. Now, underneath that, these things called set size, availability, a couple of other things down here at the bottom, I'm going to go over in detail as we move forward. So what I'm doing here is creating a CPG, giving it a name, and I'm creating what we call an FC RAID 1 CPG with all the defaults. So I'm going to just click on the Create button down here. All right. And up at the top, if we look at the, hopefully it'll show me the little green square. It's creating the CPG called FC underscore JFS RAID 1. Now, off here to the left, there's my CPG. All right, so I created a CPG. Now, I'm going to go to the mega menu and click on virtual volumes. And I'm going to create a virtual volume. Now we create a volume. You give your volume a name, the array you want to create it on. Then fully provision, thin provision. Now, I don't have any SSDs, so I can't create a thin dedupe volume. So I'm just going to create a thin provision volume. Then you give it a size. I can make it, one gig up to 16 terabytes. I'm creating a 1 gig volume. Now, here's where you need to listen up. So I'm creating a volume here. I'm giving it a name, thin, and a size. So see underneath the provisioning type, there's a little pull down that says choose the CPG. And amongst CPGs, I see the one I just created. And I'm going to choose the CPG. Now, from here, I actually want to stop. Okay. Because, and I want you to think about this, I'm on the screen here in SSMC creating a volume, right? I'm creating a volume called HP2 and it's thin provisioned. But on the screen where I'm creating a volume here, right? I'm creating a volume right here. I'm not telling the array when I'm creating a volume what the RAID level is on this screen. Do I want to create this volume from SSD capacity or nearline capacity or FC capacity? I'm not on the screen when I create a volume saying, okay, make it a set size of 2 or set size of 4 or availability cage. That is determined by the CPG, the Common Provisioning Group. So when you created that, when I created that CPG RAID 1, FC, set size of 2, availability cage, that is a policy. So when you create the volume, you just here you give it a size, thick or thin, a name, and then you say which CPG do you want to use. All right. So I'm going to stop the share here. Back in the classroom. Okay. Let's assume up here at the top. Let's just deal with this up here. These silver squares represent your SSDs. I'm going to change my example up here. Let's assume these are your, I should change the color here. Let's assume these represent your 240 SSDs across essentially 10 cages here. These represent your SSDs back here. So when you create these CPGs, these little bands here, these colors represent CPGs, not volumes. So when you create these CPGs, you give them a name. And then remember, you choose a device type. Of course, the device type here would when you create this CPG using SSD. So here these represent different CPGs created using all your SSDs that are, this is a RAID 1 set size of 2 availability cage CPG. This one down here is RAID 5 set size of 6 availability mag with a growth limit of 3 terabytes. This one here in green is said, okay, when you created, use all my SSD disks, RAID 6 set size of 8 availability cage with a different growth limit. So what happens when you create these CPGs, they are just a policy. It's not a physical thing. So let's say I want to create a RAID 1 set size of 2 CPG across all my SSDs. Well, when I go create the volume, I go in and say, well, use this CPG. Maybe I want to create a RAID 5 set size of 9 availability mag volume across my SSDs. Well, when you go in and create the volume, use this CPG called CPG4. So a CPG is a policy. It's not a physical thing. Now, some of you have worked with other arrays like EMC and some of the other HP arrays. In other arrays, clearly you have disks, but disks are grouped into some sort of physical grouping of disks, right? You have, like in the EVA, we take disks and physically group them into a disk group. You'll hear the term volume groups or parity groups or RAID groups. When I started working with the 3-part array, and I'd come from a background working with other arrays, I heard the term common provisioning group, and I said, oh, it's kind of the same thing as a disk group or a volume group. It's not, all right? It's a policy. You want to think of it like a template. So when you create the volume, you say, use this CPG, and the 3-part knows how to lay the data out as RAID 1, RAID 6, availability cage, all the things we're getting ready to talk about. You're not allocating any space when you create a CPG. It's just a policy, all right? So when you create the CPGs, if you create, you got your default CPGs, but if you want CPGs with certain tweaked characteristics, you're going to create your own CPGs and use those CPGs to create your volumes, all right? Sometimes I'll get from students, they'll say to me, well, they'll use this terminology. They'll say, well, that disk is in that CPG. Well, that's actually not the right wording. It's not the right wording, okay? A disk isn't a member of the CPG. Remember when I created my CPG, I said use all my FC disks or my nearline disks or my SSDs. So when you create a CPG, you choose the device type and then different RAID levels, set sizes, and so on here. Now, couple of things here. Remember, and I just created let me push out my share again really quickly. To answer your question, remember when you create a CPG, you give it a name, and then here I just took all the defaults, the RAID level, the device type, and so on. I haven't talked about set size, availability, and so on. This is what we're going to spend most of our morning doing, talking about what is the set size, what is availability cage. So when I created my quick CPG, I took all the defaults, RAID level and device type. So, Srikant, we haven't really talked about it yet. That's what we're getting ready to do. Before I even get into the weeds, I wanted to give you a little example, because I think showing you that example kind of at least brings the concept of what a CPG is about. It's not a physical grouping of disk, it's a policy. So this whole the past couple of days when we've been talking about policy-based array, well, we're talking about the CPG. Okay, and eventually when you create these CPGs and you use the CPG to create a volume, it determines, well, is the volume going to be RAID 1 or RAID 6 or RAID 5 or set size of 8 or 9 or whatever. That's what we got to dig into this morning. All those options, really, when you create a CPG and have these CPGs out there. Good. Good start. I'm going to wind up coming back to this slide, jumping back to this slide as we move forward. So one of the things you do when you create a CPG is you choose the device type, right? Now, in your array, you only have SSDs, so you only have one device type. So eventually your volumes will be carved out of your SSD disk. Now, if I have customers that have like the 3 media types, eventually when they create CPGs that are FC or nearline or SSDs, and they use the CPG to create a volume, that essentially dictates, whether the volume be allocated from the slower capacity, like the nearline capacity, or cheaper, or, which is cheap, right? Or the SSD capacity or the FC capacity. So one thing you choose when you create a CPG, and then you create a device, the volume determines whether, what media type the volume is going to be allocated from. So as we move forward here, now clearly in your case, you only have SSDs, so you have one device type. But as we talk about things here at CPG-wise, I'm going to talk about things from a cost point of view, and I'm also going to talk about things from an availability, and also a performance point of view. Let me spell that right. A performance point of view. So I know this won't apply to you currently since you are all at 100% SSD right now, but clearly, if people do have these media types, if they create a volume using what we call an SSD CPG, SSDs are best from a performance point of view. So they're great from a performance and availability point of view. The downside of SSDs are what? They're the most expensive media type. So if I have a customer creating some nearline CPGs and they create a volume nearline, the good news with that is what? It's cheap. The nearline disks aren't great from a performance point of view because they're slow and not great from an availability point of view. So, again, CPGs are important and really determine when an admin creates a volume what media type and cost, performance, and availability has to be taken in consideration. So when you create a CPG, okay, we support, and you create a CPG, you also choose a RAID level. We support 4 RAID levels, 0, 1, 5, and 6. All right. Now, before we get into RAID levels and set sizes and availability options and so on, we've been at it for an hour. It's actually a good breaking point here. So let's take a quick 10-minute break before we jump into raid levels and a couple of other things. I'm going to take a break myself. So, muting my phone. See you in 10 minutes.